I'm Nasser Abdelhouk, and I'm here to give online tutorial specifically on selected topics in physics. And specifically, we are going to start with the general gas law. We have what we call general gas law. When you're talking about general gas law, we talk specifically talking about the Boyle's law, the Charles law, the pressure law, the general gas law, as well as the ideal gas equation. Specifically, let's now see the first one, which is the Boyle's law. The Boyle's law, if you ask to define Boyle's law, the Boyle's law says that the volume of a fixed mass of a gas is inversely proportional to its pressure, provided the temperature remains constant. I repeat again, the Boyle's law says that the volume of a given mass of a gas is inversely proportional to its pressure, provided the temperature remains constant. Therefore, we can write it like this, that P is proportional to 1 over V. You can call it equation 1. Then we remove the, since proportionality is equal to constant, we call this equation 2. You now substitute equation 2 in equation 1. Then we are going to have the P is equals to K over V respectively. Now you make K to be subject of the formula from the equation 3. We have K times 1 is equals to K is equals to P the V. This is the equation of the Boyle's law. The equation of Boyle's law is that the volume of a fixed mass of a gas is inversely proportional to pressure, provided the temperature remains constant. And the formula for Boyle's law is the P1, V1, the P2, V2 respectively, where P is the pressure. The P1 is initial pressure in millimeter mercury, and the V is the volume. V1 is the volume, initial volume, which is in centimeter cube. The P2 is the final pressure, also in millimeter mercury, and also V2 is final volume in centimeter cube. Let's now see what are the graph of the Boyle's law. The graph of Boyle's law is we are plotting P against V, and when you plot the P against V, you are going to have a calibration curve like this. We are also plotting the P against 1 over V. You are having a calibration that have this, and this. So in a nutshell, this is the end of the Boyle's law. And remember, to solve with the Boyle's law, you will always be given 2 pressure and 1 volume when you are asked to calculate the final volume. For instance, if you have the P1 is equals to 250 millimeter mercury, and the P2 is maybe 350 millimeter mercury, and the V1 is equals to 30 centimeter cube. Now what you are going to do is you make the V2 to be subject of the formula. You can now say the V1 is equals to P2 V2. What is P1? The P1 is 250 millimeter mercury times the V1. The V1 is 30 centimeter cube is equals to the P2. The P2 is 350 millimeter mercury times the V2, which is unknown. Therefore, to find this, automatically you will define this by 350, here by 350, meaning 350 millimeter mercury divided by 350 millimeter mercury. The millimeter, 350 we cancel 350, when we have what? V2 is equals to 250 millimeter mercury times 30 centimeter cube all over 350 millimeter mercury. The millimeter mercury we cancel millimeter mercury. The V2 is equals to 250 times 30 centimeter cube all over 350. Automatically your answer will be in centimeter cube. Same applications apply to if you are asked to look for the same thing as the pressure, as the case may be. Therefore, that leads us to the Charles law. The Charles law. Now the Charles law states that the volume of a fixed mass of a gas is directly proportional to the absolute temperature, provided the pressure remains constant. I will repeat again. The Charles law says that the volume of a fixed mass of a gas is directly proportional to its absolute temperature, provided that pressure remain constant. And therefore, to do this is very simple. What we are going to do is, we have the volume of a fixed mass of a gas is inversely proportional to the absolute temperature. We call it equation 1. Then we have the proportionality is equals to K. We call this equation 2. Substitute 2 in 1. Wherever we have, anywhere you see proportionality, put K. We have the V is equals to K times T, which is same thing as VT, equation 3. Therefore, you make K to be subject of the formula, divide both sides by T. We have this by T cancel T. K is equals to V over what? T. And this is the formula for Charles' law, where we have V1, the T1, V2, the T2 respectively. That's the equation or the formula for the boy in the Charles' law. And the graph of the Charles' law is, you are plotting the V against T, where you have a calibration like this, and here will be minus 273 Kelvin. But the modification is that most of the time the temperature will be given to in the Boyle's law as theta, that's degrees Celsius. And for you to convert degrees Celsius to Kelvin, automatically you have T, which is going to be your degrees Celsius given to you plus 273, whereby you have the 273 Kelvin. That is the formula. For instance, if you are given the V1 is equals to 35 degrees and the V2 is equals to unknown, and the T1 is equals to 0 degrees and the T2 is equals to maybe 23 degrees, 27 degrees respectively. So to solve this is very simple. What you are going to do is, you are plussing this with 273 Kelvin. You are also plussing this with 273 Kelvin. Before you start solving, automatically when you plus this with this, you are going to have 273 Kelvin. When you plug this to this, you are going to have 300 Kelvin. These are what you now adapt to solve using this. And how do you do that? You can bring it down a little. We have the V1, we have the T1 is equals to V2, T2 respectively. What is our V1? Our V1 is equals to 35 centimeter cube, and the T1 is equals to 273 Kelvin is equals to V2, which is our unknown, divided by 300, and the 300 is equals to 300 Kelvin. You cross multiply. This times this is going to be 273 Kelvin times V2 is equals to, when you have this times this, which is 350, 33 and 35 degrees Celsius times 300 Kelvin. You are going to make this subject of formula. You do the same thing. Divide this by 273 Kelvin. Divide this by 273 Kelvin. 273 Kelvin divided by what? 273 Kelvin. This will cancel this. Then V2 is equals to 35 centimeter cube times 300 K divided by 273 Kelvin. Kelvin cancel Kelvin. The V2, your answer must be in centimeter cube. That's all about that, of course.